Now, today class we'll see the discuss properties of broadside array for an element uniform array. Okay, so let us start with the first property. Okay, the first property that is major. First property of Endfire array that is major. So what is the condition for the major group? The condition for the major group is the condition for major group is psi should be equal to 0. What is the value of psi? Psi is equal to beta d cos theta plus alpha. Okay. So this phase difference is due to separation or path difference. Separation or due to path difference. Due to path difference. And this is due to excitation. Due to excitation. Okay. So whereas in broadside array, all the elements are fed with the same phase. So in a broadside array, alpha is equal to 0. But in Endfire array, all the elements are different phases. So progressive phase shift is given. So in a Endfire array, the value of alpha is not equal to 0. Okay, so this is the only change between broadside array and Endside array. Okay, so psi is equal to beta. The value of psi becomes beta d cos theta plus alpha in Endfire array. Okay, so for example, if psi is equal to 0, then it is beta d cos theta plus alpha is equal to 0. From this, beta d cos theta is equal to minus alpha, or alpha is equal to minus beta d cos phi. Okay, so for example, for phi is equal to 0, the value of alpha is equal to minus beta. So for maximum value, the phase difference is it is alpha value is equal to minus beta d. Okay, therefore, what happened to the psi? So psi is equal to the formula beta d theta plus alpha, where what is the value of alpha? Alpha is equal to minus beta d. Therefore, psi is equal to beta d cos phi or cos phi or cos theta phi minus beta. Therefore, so if I take beta d common, cos phi minus psi is equal to beta d. So the expression for major root is psi should be equal to 0. Therefore, beta d cos phi x1 is equal to 0. Therefore, cos phi is equal to, therefore, phi maximum will get in 0 degrees. So in an Endfire array, in an Endfire array, maximum radiation occurs at phi max is equal to 0. Okay, so this is the first property, phi max. Okay, now let us go to the second property of array, that is magnitude of major load. Magnitude of major load. So what is the condition for magnitude of major load? Et by log for an n element array is equal to sine n psi by 2 by sine psi by 2. Okay, so the magnitude of major load, we are considering that when psi is equal to 0. To substitute psi is equal to 0, we get 0 by 0, which is indeterminate form. Okay, so whenever there is indeterminate form, we want to apply L hospital rule. L hospital rule. So what is this L hospital rule? So et by E naught is equal to limit psi tends to 0 2 by dou psi of sin n psi by 2 by dou psi of sin psi by, so that is limit psi tends to 0 n by 2 into cos n psi by 2 by 1 by 2 into cos sin by 2. If I substitute psi is equal to 0, et into 2 will get cancelled. Et by E naught is equal to f. Therefore, the maximum value it is equal to n into E naught. So this is the magnitude of, so et by E naught is equal to n, where n is number of elements in the n is number of elements here. Okay, so this is the second property. Now let us come to the third property. The third property is null. The third property. Same procedure. Whatever the procedure we have done for broadside array, the same procedure we want to proceed for Endfire array, but the only difference is there the value of psi is equal to beta d cos theta, but here the value of psi is equal to beta d cos theta plus alpha. What is the value of alpha? Alpha is equal to minus beta d. Okay, so that is the only change we want to consider. The third property is null. Okay, so the condition for null is condition. Null means we don't find any radiation. So the condition for null is sin of n psi by 2 by sin psi by 2 should be equal to 0. So in order to validate this, okay, compulsorily sin psi by 2, okay, should not be equal to 0. So the only option here having is sin, because if 1 by 0 will becomes indeterminate form or okay, sin n psi by 2 should be equal to 0. Okay, so n psi by 2 is equal to 0 means applying sin on both sides. So on both sides, what you will get? N psi by 2 is equal to plus or minus m by, where m is equal to 1, 2, 3, so on. Okay, so I am substituting the value of psi. Psi is equal to the value of psi. Beta d cos pi minus 1. Beta means 2 pi by lambda into t cos pi minus 1. Okay. I'm substituting here n into 2 pi d by lambda by 2 into cos pi minus 1 is equal to plus or minus m pi. 2 will get cancelled. Pi will get cancelled. So what is the value of cos phi minus 1 is equal to plus or minus m lambda by n. So what is the value of cos phi minus 1? You take any value. Take any value. For example, let us take cos 0. Cos 0 is 1. 1 minus 1 is 0. Okay. Or cos, what is the value of cos 90? Cos 90 is 0. 0 minus 1 is minus 1. Cos 30 or any value. If you name any value, the value of, for any value of, for any, call it as pi minimum, call it as pi minimum, for any value of pi minimum, cos pi minimum minus 1 is negative. So here we have used plus or minus. So from this, we can take only the negative values. We can take only the negative values. Therefore, cos pi minus 1 is equal to, instead of plus or minus, we take only minus m lambda by ent. Therefore, cos pi minimum is equal to 1 minus m lambda by ent. Therefore, my expression for minimum the side loops is equal to the nulls is equal to cos inverse of 1 minus m lambda by n. So this is for very important expression for getting nulls. Okay, so for an Endfire array. For an Endfire array. So phi minimum is equal to cos inverse of 1 minus m lambda by nb, where n is number of elements in the array. Lambda is wavelength, d is separation distance between separation distance, where d is separation distance between elements. Okay, and m is an integer value starting from 1, 2, 3, so on. Okay, so one expression we have got is cos phi minus 1 is equal to, this is one expression for broadside array. So we will take this one and we will derive another expression in terms of nulls. Okay, so you know that this is cos phi minus cos phi minimum minus 1 is equal to plus or minus take as m lambda by nd. So what is the value of cos theta minus 1? Cos theta minus 1 can be written as 2 sine square pi minimum by 2 is equal to plus or minus m lambda by nd. Therefore, sine square pi minimum by 2 is equal to get cancel plus or minus m lambda by nd. Therefore, phi plus or minus m lambda by n. So therefore, the expression for so so applying the sign inverse on both sides, you get pi minimum is equal to 2 sin inverse of root of plus or minus m lambda by n. So this is another expression for phi minimum. This is another expression for phi minimum. I have seen two expressions. This is one expression for obtaining null for an Endfire array. This is another expression for obtaining a null for an Endfire array. Okay. Now let us go to the fourth property of Endfire array, that is side loops. Okay, so the condition for side loops is the condition for side loops is sine of n psi by 2 is equal to plus or minus 1. So, okay, so applying sine inverse on both sides. On both sides. Okay, we get n psi by 2 is equal to plus or minus m plus 1 pi by 2, where m is equal to 0.234. Why are not considering m is equal to 0? Because so if m is equal to 0, we'll get the maximum radiation. Okay, so that's why we should not consider m is equal to 0. Okay, so n psi by 2 is equal to plus or now substitute the value of psi. Psi is equal to beta d cos pi minus 1. Beta means 2 pi by lambda into t cos pi minus 1. Substitute here. So, n into 2 pi by lambda into t into cos phi side minus 1 by 2 is equal to plus or minus m plus 1 pi by 2. Okay. So 2 will get cancelled, pi will get cancelled. Okay. So cos phi side root minus 1 is equal to plus or minus 2m plus 1 lambda by 2nt. Okay, so cos phi side root minus 1 is equal to plus or minus 2m plus 1 by 2nt. Okay, so for any value, so as I have already told that for any value cos theta minus 1 will be negative. Cos theta minus 1 will be, if you take any value of theta, okay, so cos theta minus value will be negative. Therefore, I will consider only the negative values. Cos sin minus 1 is equal to, instead of plus or minus, I will consider only the negative values. Okay, so it is minus lambda into n plus 1 by 2n. So what is the value of cos pi Sn is equal to 1 minus lambda by 2m plus 1 by 2n. So what is the applying cos on both sides? Cos on both sides, we get side roots. Side roots for Endfire is cos inverse of 1 minus lambda into 2n plus 1 by 2n. Okay. So this is the expression for side loops. This is the expression for side loops where the range of m is from 1, 2, 3, so on. N indicates number of elements in the array, and T is the separation distance. Okay, this is the fourth property. And now let us go to the fifth property. Now let us go to the fifth property, that is beam width. So as we have already told, in a Endfire array, we see the diagram of Endfire array. So the maximum radiation is along the axis of 0 degrees, 0 degrees. So this is my radiation of an Endfire array. Okay, so okay, so see here, for example, this is my first side loop. This is my first null. Okay, this is my first null. What if of the angle? This angle is nothing but pi minimum. Okay, so this is also pi minimum. Okay, or so this is nothing but so beam width between first nulls, beam width between first nulls, call it as nothing but 2 into 5 minimum. Okay, so 2 into 5 minimum. So the angle from here we can call it as 5 minimum. Okay, so it is nothing but 2 into 5 minimum. Okay, so already we have derived the expression for 5 minimum for a broadside. We have derived the expression for 5 minimum of a broadside array. So what is the 5 minimum of a broadside array? So the 5 minimum for a broadside array is 2 sine inverse of plus or minus m lambda by n. Okay, so what is the minimum value of 5 minimum? 5 minimum is equal to 2 sine inverse of plus or minus m lambda by 2n. Okay, so applying sine on both sides, sine 5 minimum is equal to sine 5 minimum by is equal to plus or minus of m lambda by 2n. Okay, so since if 5 minimum, if 5 minimum is very, very less than sine 5 minimum is equal to 5 minimum by 2. Okay, so therefore, substituting here, instead of sin pi minimum by 2, I can replace with pi minimum by 2 is equal to plus or minus of m lambda by 2 nt. Therefore, pi minimum is equal to plus or minus root of 4m lambda. I am transferring this to this side. Okay, 4m lambda by nt once because therefore pi minimum is equal to plus or minus m lambda by nt. So this is the right. Now what is the formula for the PV? PV is nothing but 2 into 5. 2 into 5 minutes. Therefore, the PV between first months is equal to 2 into 5 minimum. That is equal to plus or minus 2 into top 2m lambda by nd. Okay. So therefore, PV between first null is equal to plus or minus 2 into root of root of 2 for m is equal to 1. Okay. For example, for m is equal to 1. That is for first side, for first side loops. So m is equal to 1 means 2 lambda by e and t radians. This is in terms of radians. So p with between first nulls is equal to root of 2 into 2 lambda by e and t. Okay, so if I express in degrees, 1 radian is equal to 185 pi degrees, that is 57.3 degrees. So simply multiply with 57.3 months is equal to 2 into plus or minus 57.3 into top 2 lambda by and 8 degrees. So what is its value? Between first two months is equal to 114.6 plus or minus 2 lambda by and 8 degrees. This is in terms of radians. This is in terms of degrees. Okay. Similarly, we calculate half power beam. So half power beam width. We know the relationship between first null and half power beam width. It is half power beam width is equal to beam width between first null by 2. That is equal to plus or minus 2 half 2 lambda by nd. This is in terms of radians or in terms of degrees is equal to 57.3 plus or minus 2 lambda by nd. This is in terms of degrees. Okay, so these are the different formulas for the Endfire array of the